binary logistic regression with one binary predictor or one categorical predictor in SPSS. Binary logistic regression for a predictor that is binary in SPSS. Logistic regression is a statistical test that can be performed when the outcome or the dependent variable or the response variable is binary, which means that it has two categories in it or two levels. Yes, no, have disease, doesn't have a disease, have diabetes, doesn't have a diabetes. And the second variable, which is the independent variable or the exposure variable or the explanatory variable, can be binary. Again, binary means that has two levels in it, such as the sex or the gender, male or females. To perform the binary logistic regression with a binary predictor, the outcome has to be binary and the predictor has to be binary. The objective of doing binary logistic regression is to find out whether there is a relationship or a link or association between the predictor and the outcome, and whether the predictor can predict the outcome. Here in this SPSS data sheet, I had inserted 100 cases or participants. There are two variables here, one for gender and one for heart diseases. So the first one, which is the gender, is a binary or binomial variable, have two levels in it, males or females. If I click on the variable view and click on the values for the sex, 0 is assigned for females and 1 is assigned for males. So here we have one variable which is binary or dichotomous, have yes or no, or have male or females in it. 1 for male and 0 for females. The second variable, which is heart diseases, whether you have a heart diseases or not. If we click on variable view, then in values, and the 0 value is assigned for no heart diseases and 1 is assigned for heart diseases. So here we have a variable which is binary. If I click on that icon, you can see it's coded 0 or 1. So here we have two variables. One of the variable is the outcome, which is the heart diseases, whether you can get a heart diseases or you will not get a heart diseases based on the data inserted here. So to find out whether there is association or relationship between the gender and possibility or probability of getting heart diseases, binary logistic regression can be performed. And the condition for performing that test is fulfilled, as there are two variables. One of them is the outcome, which is binary, and the other one, which is a predictor, which is also a binary. Before we start, let's check the frequency for each variable. If we click on Analyze Frequencies and then drag the 6 to the variable box and the heart diseases, click on Statistics and nothing to choose from here. Let's just click on OK. Again, multiple tables are generated. The first table shows that there are 100 cases with no missing values for sex and heart diseases. For the first variable, which is the predictor, which is the sex, there are 52% of female and 48% of males. And for the heart diseases, 44% have no heart diseases and 56% have heart diseases. To perform logistic regression binary, click on Analyze, scroll down to Regression, and then scroll down and select the binary logistic regression. Reset that window, and in that window, since we know that the heart diseases is the outcome or the dependent variable, this is the variable we want to find out whether the predictor, which is the sex, which is a binary, can predict probability or possibility of having heart diseases. Drag that into the box here. Since we have here a predictor that is binary or categorical, click on categorical, drag the 6 here. Although it is just having only 2 levels in it, I'm going to set the 0 for the first, which means that male will be compared to females. Click on continue. For options, I'm going to select classification, plots, Hosmer, goodness of fit, and confidence interval for the exponential p. Click on continue, click on OK. Multiple tables are generated. The first table shows a summary for the case or cases. As shown, 100 cases, no missing values or cases. The second table is the dependent variable, which is the outcome, which is the heart diseases. As shown here, it has been given a value of 0 for no heart diseases and 1 assigned for heart diseases. And for the categorical variable coding, females are given a value of 0 and male are given as a value of 1. Moving to this table, which is variable in the equation, this is a very important table, shows here the coefficient value and the test which is used for binary logistic regression, which is called Wald test. Standard error is generated, and degree of freedom, significant p-value, and exponential p, which is the odds ratio. Moving to the section here, which is for method enter, the important table also here is the model summary. A model is generated by trying to fit the predictor into the outcome to generate a model in which the possibility of the predictor can predict the outcome. Again, looking at the R square here, which is the value here, which is 0.735. This value means that 73.5% of the variation in the outcome, which is the heart diseases, whether you have a heart disease or not, can be explained by the predictor, which is the sex, whether male or a female. So the sex or the gender of individual can explain the variation in the outcome. Jumping to the last diagram here, which is very important, as shown from this diagram, predicted probability is of the membership for HD. So we are here calculating the probability or the chances or the odds for heart diseases, possibility of heart diseases. The table here is also an important output for the interpretation of the result from the analysis, binary regression. There's a value is given here for the coefficient, the standard error, the Wald test, the degree of freedom, significant as it is less than 0.05, and 95% confidence interval for the exponential, which is the odds ratio. This is for the predictor or the variable, which is sex, and again given a value of 1. Here we are comparing the males to females. So the way to read this result or interpret this result, it shows that there is a significant association between the outcome, which is possibility of getting heart diseases, and the predictor, which is the gender of the individual. As shown here, the males have a 224.5 odds of having heart diseases compared to females. So the males had an increased chance of getting heart diseases with an odds of 224.5 related to the females. So this is the way to perform binary logistic regression with an outcome that is binary, which has 2 levels in it, and a predictor, which is binary, have also 2 levels in it, to find out whether there is a relationship between both variables and whether the predictor can predict the outcome. Binary logistic regression with categorical predictor in SPSS. In this SPSS data sheet, I had inserted 200 cases. We have here two variables. The first variable is smoking. The second variable, whether you have cancer or no cancer. The first variable is a categorical variable. It's multinomial variable because it have in it four classes or four categories: non-smoker group that smokes cigar, groups that smokes pipe, and groups that smoke cigarettes. So there are four classes or four categories in the first variable. So it is multinomial variable with four categories in it. Cancer, whether you have cancer, yes or no. So this variable is binary or dichotomous or binomial. So we have here two variables. One of them is categorical and the other one is binary. So the outcome here is the cancer. So cancer is binary and the smoking is a predictor. To find out whether there is a relationship between smoking habit and developing cancer, then binary logistic regression can be performed to find out whether there is a link or relationship, or whether smoking habit can explain the variation in the outcome or can predict possibility or likelihood of getting cancer. As here the outcome is binary and the predictor is a multinomial. Before proceeding into doing the binomial logistic regression, let's start do some descriptive analysis. If we click on analyze, then descriptive statistics frequencies, select both variables and drag them into the variable box, and then click on OK. Multiple tables will be generated. As shown in the first one, there are 200 valid cases for smoking and cancer and no missing cases. For smoking, there are 200 cases, 50 cases non-smoker, and similarly cigarette, pipe, and smoking cigarettes. And for cancer, 200 cases, half of them have cancer and the other half doesn't have cancer. To do the binary logistic regression with this predictor, which is smoking, and an outcome, which is cancer, click on analyze, scroll down to regression, and then scroll down to binary logistic regression. In this new window here, since our outcome is the cancer, then drag that to the dependent empty box here. And for smoking, since smoking is a predictor, drag that into the covariate. If the predictor was continuous, then also drag it to the covariate. If the predictor also ordinal, then drag it into the covariate box here. Click on categories or categorical. Since smoking have four categories in it, then drag that into categorical covariates, and we are going to set the non-smoker as a reference group, which is given a value of 0. And it's going to be first as selected here. Click on continue, and then click on options. For options, click on classification, click on Hosmer, and click on CI confidence interval for exponential p-value. Click on continue and click on OK. Before interpreting the result, let's look at the assigned value for each categories by clicking on the variable views, and then click on the smoking values. Non-smokers are assigned a 0 value. This is going to be the reference category to compare to. Those who smoke cigar, given a value of 1. Those with pipes smoking, given a 2, and cigarette 3. So back again to the output for the binary logistic regression. The output here shows that there are 200 cases in the first table with 0 missing values in both variables, smoking and cancer. For the smoking table, again, the 4 categories, each category has 50 cases in it. For cancer, there are 200 cases and 100 cases of having cancer and 100 cases without cancer. Moving to the next section here, which shows that the dependent variable here, which is the outcome, which is the cancer, is assigned a value of 0 for no and 1 for yes. Classification table also shows how many cases are having cancer and how many doesn't have cancer. The next table is variable in the equation. It shows here the coefficient value, the standard error, the Wald test used for doing binomial logistic regression, degree of freedom, significance, and exponential p-value. Scrolling down to the most important table, which is the model summary. This table shows that by looking at this value here for R square, it can be explained that 11.7% of variation in the outcome, or whether you have a cancer or not, can be explained by the predictor, which is the habit of smoking. The next table here, we need this value here to be greater than 0.05. Scrolling down toward the end, there is a graph here. It shows that the predicted probability is of a membership for yes. The most important table in the whole output is the table with variables in the equation. As shown here, we have a categorical predictor with 4 levels in it. The first level, which is non-smoker, are a reference group, which is not showing here. The group which is assigned a value of 1 for those who smoke cigar, 2 for pipe, 3 for cigarette. As shown here from the significance, this one is significant, this one is significant, this one is significant. So there is association or relationship between smoking, whether cigarette or pipe or cigar, with the probability of having cancer. As shown here, the p-value, the coefficient, the standard error, the Wald test, the degree of freedom, and significant. An exponential p, which is the odds ratio. And then 95% confidence interval for the odds ratio is given here, as those two values are significant for determining whether the result are significant or not, the p-value and the 95% confidence interval. The way to interpret the result is by stating that those who smoke cigar have 2.7 odds in getting cancer compared to those who do not smoke or smoke at all. So there is a higher probability that those who smoke cigar will develop cancer, and this is significant. For the second category, which is smoking pipe, as shown here, smoking pipe, those who smoke pipe have higher odds compared to those who do not smoke any kind of tobaccos. So those who smoke whether pipe or cigar are more likely or have higher chance of getting cancer. For the final category, which is cigarette, those who smoke cigarette have 6 times higher probability of getting cancer compared to those who do not smoke at all. So there is a variation in the odds ratio with each categories of the type of smoking, but all of them smoking any type of tobacco products increases the chance of getting cancer. This is the way to perform binary logistic regression with an outcome that is binary or binomial, and a predictor that is categorical or multinomial, consisting of at least 3 categories, to find out whether there is a relationship or association between the predictor and the outcome, and whether the predictor can predict the outcome and the variation in the outcome can be explained by the predictor in SPSS. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovie, R Statistic or Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovie, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.